Hello everyone, thank you for joining me. What I would like to do with this video is go over our assignment number 2, where I will be asking you to practice the art and effort that comes with drawing concrete sketches. Similarly as assignment number 1, where you were asked to do steel sketches, we're going to do concrete sketches for this one. And I'm going to walk you through, my expectations for this. So the first one we have here is S1 pile cap. This is what's going to be expected, and I think it's been asked of you in project brief number 2. The one thing that I'm going to point out here for this is, in addition to the notes that you see here, SciCast concrete column, SciCast concrete pile cap, and then this is what I want you to pay attention to, the dimensions. Right here it reads 1600 by 1600 by 762. You need to use whatever your project brief is asking you to use for dimensions, and if it doesn't, use these dimensions, okay? 1600 by 1600 by 762. Similarly, for the concrete pile caps, or the concrete piles, the precast concrete piles, use the same thing. If the project brief you're using gives you different dimensions, use those dimensions. Otherwise, you can use 325 by 325 or even 350 by 350. And again, all of these dimensions are metric in millimeters. Okay, next one. All right, S2 is details of the precast concrete pile. So again, here, I'm just going to point out again the dimensions of the concrete pile. Here it shows in plan as 325 by 325 or 350 by 350 or whatever is specified in your project brief number 2. If it isn't specified, use 325 by 325 or 350 by 350 as long as it matches whatever you had on S1. Okay. The other thing too is you want to show the precast. This is made out of precast concrete, the horizontal rebar, and the vertical rebar. Now, I want to point out this, okay? I know that you've been taught how to do this, but I just want to point it out because it doesn't show super clearly here. When you write a note like this, you write the words, like in this case, say vertical rebar, and then the note must always be connected by way of a leader to something. And the way this works is you always have a horizontal portion and then something at an angle. Okay, now see here how that's just a straight arrow. You don't want that, so you want to rearrange these so it's always done in that fashion, where there is a note, a horizontal portion, then a leader at an angle, and then the arrow that points to something, not through something. Lovely. Okay, as we keep going then, here, so this is the plan. Here you're showing the elevation, and for the elevation you're going to show the cover here, the embedment of the pile cap at 140 millimeters, and then a note that says that the rebar is specified and that the specs of the rebar are shown in the manufacturer drawing and the shop drawings. Last thing I want to show is the steel shoe. S3, the next one will be the pile cap, the lower layer of the rebar, because then in S4 we're going to show the upper layer of the rebar. Okay, so again, S3, the lower rebar, and what we're going to show for it are in the top layer, you're going to show 7 12M bars at 58 millimeters on center. Notice how you didn't write the millimeters, just at 58 on center, and you want to make a note that says each way. Okay, then you want to show the pile below, and you want to make it dashed, right, because it's hidden. And what do we have? Here we also have 4 350 by 1400 15M dowels. Now the 350 by 1400 refers to the fact that this dowel is shaped, I'm going to try to draw it better, shaped like an L, where this dimension is 350 and the vertical dimension is 1400. You'll see this better when we show the elevation of this detail. Okay, but you want to make sure that you point to it because all 4 are there. then an indication that points to drawing S5. You want minimum, I'm going to recommend 100 millimeter cover each way. And then these dimensions all shown, right, with all these breakdowns. And make sure that this dimension here and this dimension here matches whatever you picked for the piles, right? If they're 350 by 350 or 325 by 325, because then it will get these dimensions or these dimensions to change, okay? All right, and if it fits, you also want to repeat all of these dimensions on this side. Lovely. Let's move on to S3. S3 right here, this is the top layer, the upper rebar layer for the pile cap, the reinforcing. So what you see here is 12 12M bars at 146 on center, and 11 12M bars at 146 on center. Okay? And the reason there is fewer in this direction is because they start further in, right? There's a little bit of an overlap here. Okay? And again, here's this dimension, again, needs to match the ones from the previous drawings. Use a minimum of 70 millimeters cover. So that's the distance between the outer layer of the concrete and the closest rebar edge. And I think that's it. Make sure you point to S5 for that. And then an indication of whether you have a round or a square column at the top. And these are the dowels that I mentioned earlier on, those L-shaped dowels. Now S5, what do we have here in S5? This is the cut through, right? The reinforcing of the pile cap. So you can see the two layers. I'm just going to point to them, right? This is the upper layer of the reinforcing, and this here is the lower layer of the reinforcing. I'm just showing it so that it makes sense for S3 and S4. Then, let's see, what am I showing here? Yes, the overall depth or thickness of that pile cap, 762, or whatever's in your project brief number 2. These minimum covers, so that's 140 millimeters here, 70 millimeters here. Again, cover is a distance from the concrete surface and the closest steel surface. So it's this clear distance, okay, right here. Another way to look at it is how much is the thickness of the concrete that's covering the steel that's closest to the surface. So it's 70 millimeters. Here it's 70 millimeters, I believe, and then here it's 140 millimeters. Then you show also the pile, which one is the lower steel, the fact that this rebar, right, the lower layer, is actually 12 bars of 12M bars. So it's 12 M bars at 146 on center. And these ones here, right, they're going perpendicular in and out of the page, are 3 15M bars at 190 millimeters on center. And this here is that 350 by 1400 15M dowel, right? This one here, the one I was referring to earlier on. Okay? Lovely. This is S5, the intermediate rebar for the pile cap. Moving on to S6, the round column detail. So for this one, pretty much all that you see here, I'm going to note some things to check for and remove. First of all, cover. The cover is going to be 38 millimeters everywhere, and again, that's the clear distance, or how thick the concrete is that's covering the steel, right? So that's this clear distance here, 38 cover. Then you want to use 16 gauge wire ties to tie every little bit of rebar here to this circular cage spiral tie. Okay? 16 gauge wire ties. Now, these spiral ties are going to be 15M spiral ties. I don't need you to write down what the diameter is of that. If it's 15M, we know what its diameter is and refer to the lectures for that. And here, for this note, 8 20M bars longitudinal, you do not need to write down that they're 19.5 millimeters in diameter. Okay, now for the important part. A reminder that the cover is going to be 38 millimeters, right? So again, that's how thick is the concrete that's covering the steel on the outside, 38 millimeters. This value here, 560, which is diameter of the circular column, it's either 560 or whatever is expected in your project brief number 2. So say if you have 610 millimeters, that's what the diameter needs to be, which means that these numbers might change, right? If this number changes and these two numbers stay the same, then these two numbers change. Okay? All right. Next. So here's a round column detail. This is cutting through it. S7. So this one basically stays unchanged. You're going to show the longitudinal rebar right here. This is the 20M longitudinal rebar. You're going to show the 16 gauge wire ties that fasten the 15M spiral ties to the 20M longitudinal bar. You're going to show this pitch dimension. We're going to pick 200 millimeters just to pick one. The concrete cover stays at 38 millimeters. Okay, so that's the how much concrete is covering the outsidemost steel. You want to add this note here just to make sense, otherwise it's unclear. And the last thing you have to check is this number. That's going to be as according your project brief. If it's 560, you use 560 millimeters. If it's 610, you use 610 or whatever's in your project brief. S8. This is the square column, detail number 1. So a lot of things that are similar as the circular column. We'll start with the dimensions here. Okay, this number here needs to be whatever you have, the overall width, whatever you have in your project brief too. So if it's 560 millimeters, yes. If it's 610, change it to that. If it's whatever other number, change it to that. These two numbers stay unchanged. This is 65 millimeters. It's the distance from the outside surface to this rebar. Okay? Again, the distance from this rebar to this outside surface. Which means that these two dimensions might change. Right? Okay, so make sure you do that correctly. Then you're going to show also the 38 millimeter concrete cover, which is the distance from the outside concrete and the closest steel. So that means to see this line here, this needs to project all the way through to show that it's going from the steel. Okay? You also want to show that you have 8 25M longitudinal bars, right? That's 1, 2, 3, 4, 5, 6, 7, and 8. You also have 2 15M ties at 400 millimeters on center. So the 2 15M ties, you see them pointing at, this is one and this is the other. And again, I'm drawing these leaders poorly. You're expected to draw them properly. Leaders always go horizontal, then at an angle, and they point to whatever they're pointing to, not through. And finally, you want to show the 16 gauge wire that's tying the ties to the longitudinal bars, and an indication that you're using 38 millimeters cover from there. Okay. Next drawing right here is S9. So this is the flat side underside view. And I guess this is a good place to go to talk about isometric drawings for this assignment number 2. If you want to do isometric drawings for this assignment number 2, I'm okay with that. Okay. As with assignment number 1, you can choose to do a side view or an isometric view. The isometric view is better because it shows more, but you're welcome to do a side view, whatever works best. You just have to work with whatever Ask sheet drawings I've posted for you. Okay, so for this isometric drawing, we're showing the underside of the slab. So you're showing the column, the round or square column according to the project brief. There's a drop panel around that column. This drop panel needs to be in accordance with your project brief. So if your project brief says that drop panel is 1400 by 1400 by 60, that's what you use. If your project brief says that that's 1100 by 1100 by 65, that's what you're going to use. Okay? And a reminder that drop panels are there to prevent that column from punching through, right? You're thickening the column, you're thickening the slab around the column, so it's harder for that column to punch through. Okay, then you want to show the thickness of the slab here, 220, or as according to your project brief. So if in your project brief it says 210 millimeters, that's what you're going to show here. And lastly, you want to show the rebar, which is 10 M bars at 140 millimeters on center. And that's going both ways, right? Longitudinal and perpendicular. S10, another isometric view. So it's up to you what you want to show. I'm okay if you want to do the isometric view. I'm okay with that. So super quickly, you're going to show, this note that says that you're using round and or square columns according to the project brief. Here you're going to put the long and the short dimension, and by that I mean you can either write what that dimension is or simply write it as long and short. Okay, just in case you have different different spans throughout your grid lines. So I'm okay if you just write the words long and short. Now here and here and here and here, you have to check these dimensions. Okay, so I'm just going to erase this for a moment. So here you have slab thickness. Okay, that's 220 millimeters, or as shown in your project brief. So if your project brief says, I don't know, 210 millimeters, that's what's going to show here. Here, 560 and 660, those are the dimensions, the width and the depth of the perimeter beam or the concrete beam that you have. So this should be according to your project brief. So if your project brief says that your concrete beam is going to be 610 deep by 610 wide, that needs to be reflected here, or whatever else might be on your project brief. Okay? Now, two-way slab rebar layout 1. This is S11. So what we're showing here is a sketch, kind of the two-way slab rebar layout. So you're seeing through it, and you're showing what it looks like going one direction in the long direction, and in one direction in the short direction. Okay? So this is what this refers to. The long span showing these two, which are these two. So it's going to be whatever this long span is, and I'm okay if you write long span. And then the bent rebar is going to look like this, right? It's going to have a bend at 127 millimeters, and then it's going to continue for 1000. Here for the short span right here, which is this rebar here that you're showing going this way, you're going to show the short span and then the same bent configuration, and then a straight portion of 700 millimeters. What you want to show here is this kind of note that says that this is a typical structural bay, and you're going to have alternate bent and straight bars at a spacing at 250 on center. You want to point towards drawing S13 here, that's important, and then down here you want to add these notes so that they match up with all of these, right, so that you know what they are. So here in the long direction, they're both 15 M bars. The straight one are at 250 millimeters on center. The bent ones are at 250 millimeters on center. And the short ones, the ones in the short span, are both 10 M bars. The straight one is at 250 millimeters on center, and the bent one is 250 millimeters on center. Okay. And here in this isometric drawing, you're basically going to show again what this layout looks like, right? With the spacing between the bars, that long portion, and the spacing between the bars in that respect. And you want to make sure you don't forget to put this note here. Partial view of 10M and 15M rebar layout. 10M rebar layout. The 15M bars are not shown for clarity. For drawing S13, this is the slab and beam detail mid-span. Okay, so where the slab is attached to the slab here, the slab right here, how it attaches to the beam right here. Okay, so you can see how the slab, right, the slab has this bent portion here that continues at 127. Okay, this is 10M bars going in the short direction, 15M bars going in the long direction right here, right? These are all 15M bars here. Okay. These dimensions here, this one here, and this one here, you need to be careful with those because they depend on your project brief. This one here is the depth of the beam. So you're going to use 660 millimeters or as specified in your project brief, say if it's 610. And this here is half the beam width. So, you know, whatever in your project brief you have, you divide by 2. This you can keep here at 700. You want to show that the beam has 10M stirrups, and then in this direction it also has 7. 1, 2, 3, 4, 5, 6, 7, 20M bars. Okay? And then make sure that you make this note here. Provide 38 millimeters cover for beams and 19 millimeters cover for slab. So again, the cover is how much concrete thickness is covering the outermost concrete, the outermost steel, pardon me. Okay. S14. So this one here, this is the connection between the slab and the beam at the perimeter column. Okay, so this is basically here the column, the beam and the slab looked at in the opposite direction. So that's why you see this big thickness, because you're cutting through the slab and the beam. Now this value here, 880, that needs to be confirmed depending on your project brief 2. So for example, if in your project brief 2 you have the slab as 210 and the beam as 610, this comes out to be 820, not 880. Okay, so make sure you check that. This 700 stays as 700, right? That's the distance of the bent of the straight portion here. And then what else do we have? You want to show that these longitudinal bars are 20M, and then you want to show all of these notes pointing to the various items. So the round or square column, the 10M bent bars, the 15M bent bars, the 20M bars that are going longitudinally and then bent, the 10M straight bars, the 15M bent bars, and the 10M stirrups. These guys here, the vertical ones that you see here, those are the stirrups. Now notice how this rebar hooks, goes up like this, and this rebar hooks, goes down like this, whereas the top portion just continues. Okay, so you want to make sure that you show that, and here are the details of those hooks. Right, the 20M bar at the top and the 20M bar at the bottom have hooks. This hook goes 450 millimeters, this hook goes 350 millimeters with radius of 120 degrees. Okay, sorry, 120 millimeters. Okay, all right, and what else? You also are going to show the stirrup, so these ties right here, right in the column, which came from the previous drawings. Almost there, almost last drawing. This one here is going to be the shear wall detail. So for the shear wall detail, what you want to do is show something like this. Isometric is perfectly fine. You want to show the property of the concrete, where you have 20 MPa concrete, and then you want to mention what kind of bars you have. You're going to have 10 M bars at 140 millimeters on center, horizontally and vertically. Okay, so that's what these are that you see poking through. This number here, it needs to match whatever's in your project brief too. So if it's 200 millimeters, yes. If it's 210 millimeters, yes, show that. If it's something different, show that. And then last but not least is a bonus one. I'm not sure if your project brief includes a connection between a CMU wall, but basically this is what you have. It's a connection between a CMU wall and a concrete slab of some sort. So for example, what you have here is a concrete slab of some thickness with reinforcing, longitudinal and perpendicular, right? You see it here. And then what you've done is you've cast some dowels here that bolt through two angles, right? They bolt through two angles, and the angles are shown here. They're 100 by 100 by 6 times 400 millimeters long, see right here, complete with two 15 millimeter Hilti KB3. Those are anchors. They're expansion anchors. And the L's are spaced, the angles are spaced at 1200 millimeters on center. You want to ensure that there is a 38 millimeter gap between the top of this bond beam and the underside of the slab. And you want to indicate what this bond beam is. Low web CMU bond beam course, complete with one 20 M bar solid grout. So here's the 20 M bar, and here is the solid grout. Okay. And lastly, you want to indicate what this CMU wall is. 250 thickness CMU wall, unless you have something different in your project brief. You want a 3 millimeter joint or whatever specified in your project brief. The reinforcement will be at 400 millimeters. Okay. And then you have these specs. So you have that the CMU is hollow, for H for hollow, 15 MPa strength, density is 700 kilograms per cubic meter, and O is for non-moisture controlled. Now if you don't have this connection, or the need for this connection in your project 2 brief, I'm okay if you don't do it. So it's okay if I forget and ask you, hey, where's S16? They remind me, no, we didn't have that in project brief 2. That's it. Okay, that's nothing else that I want to chat about. I hope this is helpful to you and that it helps you with your project brief number 2. Thank you for your time.